Today we are discussing aberration in optical system. Aberration को हिंदी में विफ्तन कहते हैं. Aberration means deviation from the normal behavior. So in optical system, if the lens behaves abnormally, then it is called aberration. Here optical system means the lens. It may be lens, it may be mirror, and the combination of lenses. But in this discussion, we are limited to lenses only. So aberration means if the optical system behaves abnormally, then we call it aberration behavior of an optical system. Means if we make the image from the point object, then the image must be point image if the optical system is free from aberration. But in the presence of aberration, the image of a point object is not always point image. So the definition of aberration is an aberration is any failure of optical system to behave precisely according to the simple formula of optics. So if a point object is under consideration, here we consider point object, not the extended object. So if then the failure of optical system to form point image of this point object is called aberrations. Now aberrations are divided into two categories: chromatic aberration and monochromatic aberrations. Monochromatic aberrations are also called Siddle aberrations. Monochromatic aberrations occurs due to the defects due to wide angle incidence and peripheral incidence, which occurs even with monochromatic light, are called monochromatic aberrations. Which means if the incident rays are incident on lenses, these incident rays are far away from the principal axis, then this aberration is called monochromatic aberration. These monochromatic aberrations are 5 types: spherical aberrations, coma, astigmatism, curvature of field, and distortion. And chromatic aberration, this is due to the dispersion of light, and it occurs when the light contains at least two wavelengths, which means if we consider white light, then the chromatic aberrations occurs. Chromatic aberration, now it is the ability of optical system to form the point image of the point object due to variation of focal length with respect to lambda. Here we should understand that the refractive index of the material of lenses is different for different wavelength, such as red color has refractive index less than that of violet. So the light passes in red color faster than in the violet color. So hence the focal length of lens is different for different wavelength. We know from the lens maker formula that the focal length is connected to the refractive index. So for small refractive index, the focal length is higher, As the magnification of the image is dependent on the focal length of a lens, the size of image is different for different wavelength colors. Hence, the variation of the image distance from the lens with refractive index measures axial or longitudinal chromatic aberrations, and variation in the size of the image means lateral chromatic aberrations. Here we understand this one from the figure. So if this is the lens and if the incident rays are coming from infinity, then this is the white rays containing 7 colors. So we know that the refractive index of red color is minimum. So the focal length is maximum. Focal length can be written by this equation, this one. So for a smaller mu, the focal length is larger. So this one is f, and if mu is small as for violet color, so the focal length is small for this violet color. Here we can see that the image of an object which is situated at infinity, the image of this object is not point image. This is point P1, this is point P2, and it is displaced between P1 and P2. So this is the case of an object which is situated at infinity. If the object is like this one, extended image, and its rays are incident on lenses, then the red color are when the red color coming from, since the red color have larger focal length, so this form the image at B dash E dash, and violet color have a smaller focal length, so it forms the image at B dash E dash. If we measure the displacement B dash and B double dash, then this displacement is called longitudinal chromatic aberration, which is along the principal axis. This one is the principal axis, and if we see the lateral chromatic aberration, which is the difference of this one, this is the image for violet and this is the image for red. So this difference is called lateral chromatic aberration.